Welcome everybody. Again, I'm Paul Anderson and this is Gail Anderson, and we're going to be having a talk tonight on JavaFX now and beyond desktop and mobile. Before we get started, how many folks out there are using JavaFX? Anybody? Cool. All right. So you guys will probably know some of the things that we're going to show you. For the rest of you, this will be very interesting to see what we're going to be presenting for how to use JavaFX to design UIs not only on the desktop but also on mobile. Okay, so Paul introduced us a little bit. Gail and I have a training company. One of the good things about speaking here with Paul is that we actually live in San Diego, so don't have to get on an airplane and go anywhere. In fact, we're out here in Encinitas. We've been into Java a long time. In fact, I taught Java to the U.S. Navy in 1997. I taught the first Java course for the Navy. The Navy's very big into Java, by the way. Gail and I have been into Java for quite a while, and we've really seen a lot of it evolve. And we not only do Java and JavaFX courses, but of course I have a very strong C++ background. I'm also teaching Go and Python. So, you know, we're doing kind of the whole spectrum of different programming languages these days. Gail and I have also written 8 textbooks on software programming. We've written books on C++ and Java and other ones. This is our latest book a couple years ago, JavaFX Rich Client Programming on the NetBeans platform. We also have a couple of videos out there too by Pearson Education, JavaFX Programming and Java Reflection. These are available for viewing and stuff, and so forth. And just recently, Steve Chen, who runs, kind of in charge of Java at Oracle, asked us to write a chapter to a new book that's coming out later this year. This is going to be an A-Press book. It's going to be called The Definitive Guide to Modern Java Clients with JavaFX. And Gail and I wrote the Fundamentals JavaFX chapter for that. And there's a lot of Java champions like myself that are writing chapters for that book. So for those of you guys that are into JavaFX, you might want to take a look at that book when it comes out later this year. Okay, now we're going to do 2 talks tonight actually, part 1 and part 2. And this first one we're going to do right now is part 1. And what we're going to do that I think you'll find interesting is we're going to, we've designed a standalone JavaFX application that runs on the desktop. And specifically, it handles blood pressure readings, okay? And we designed the whole thing in JavaFX so that we could use it to teach people JavaFX techniques and UI design and so forth. So we're going to, Gail's going to demonstrate that for you in a few minutes, and that's the first thing that we're going to do. And then what I wanted to do that I think you'll find interesting is I wanted to focus on areas of JavaFX that make it very powerful for doing UI programming. And what we'll do, since a lot of you don't know JavaFX, is we'll introduce JavaFX Properties to you as they work with model data, and then we want to show you how to write listeners and attach them to these JavaFX properties. And then I want to go over the really nice binding strategies that you have in JavaFX. These are really wonderful ways to deal with UI scenarios that can be quite complicated. And with these listeners and binding strategies, you'll end up writing less code, it'll be more concise, and it will be easier to implement. We'll also introduce the concept of observable lists so that you can have lists of data and get notified when something gets added to the list or so forth. And then the code that we're going to be showing you tonight has lambdas and streams. Okay, so it's Java 8 and above, and we are actually going to show you how you can do a JavaFX binding with streams as well. So I think it's going to be, and we'll be showing you guys some code tonight, and you'll get to see a lot of that that's going on. Okay, so I'm going to turn over to Gail right now, and she's going to run our first demo application here, which again is a standalone application that is all written in JavaFX. And we'll use this to go through some UI scenarios and show you how you do some of these techniques.
Hi, everybody. So the first, I'm using NetBeans here, but you can use any IDE of your choice. I'm going to run this program called BPMonitor, and it's not a super complicated program, but we put it together just to show different, as Paul said, different UI behaviors. So we've divided this application into 4 areas. On the left here is a table view, and it displays some data, and all this data was inputted previously, it's just hard-coded in here. And we use a split screen, or a split panel, I guess is what it's called, to lay out the data. Over on the right, we have a JavaFX chart. JavaFX includes charts by default, and the charts then display the data that is in the table view. So we can select different components, and then we show which reading that we've selected by using a drop shadow effect. We can also select the data in the chart itself, and then over here in the table view, it will also be displayed. The third area down below is also a chart. This is a bar chart, and we use this to display stats for whatever readings are displayed above in the line chart. So this is the maximum for the systolic, diastolic, and pulse data, and average and minimum. And then finally, the fourth area over here is a set of UI input controls where you can either delete a reading, add a reading, or update a reading. And so what we're trying to do is show you in this is why JavaFX is, what are some of the features, the benefits of using JavaFX. And Paul's going to be going more into that, but one of them is that JavaFX supports observable data, and that means by observable, that means you can attach either listeners to data fields, or you can also use it in binding expressions. The other thing that it supports is observable lists, which is the same thing. You can detect when you add or remove something to a list, or detect changes within a list. And in this application, we use a combination of lists. So we have a backing list that has the data, it's unsorted, and then we have a sorted list that wraps it. Now, sorted list is read-only, and you give it a comparator, so it's very flexible. In this case, the comparator is based on the date, so we sort the readings based on the date. And then we use the third list, which is a filtered list, and you can give it a predicate. So we use that to select a range of dates that we display. We don't display all the readings at once, but we just go through. And so we can use these controls here to step through. Let's see. Okay, I think that's
Yeah, okay, that's good.
so.
Okay, now the plan here is that we're going to take the program that we have, and we're going to go and show you some typical UI scenarios that you have to write code for to handle. And then we're going to show you how to do this with listeners and binders, and particularly looking at some of these binding strategies. So back in the notes right now, the first thing we want to talk about is a fundamental notion in JavaFX, which is the idea of a property. So the idea is that when you're in a class, normally you have fields for your data, right? But what we're going to do is, instead of having a field inside of a class, we're going to have a property. And this property is going to wrap the field value, but make it observable, which means that when that field gets updated, somebody can be notified that it's been changed. And so, JavaFX makes this really easy to work with because you can attach a listener to a property, or you can use a bind expression for that property. And when, once again, when the field that's living inside that property gets updated, you can be notified in some way. And the implementation of all this is very easy to do and very easy to write, and particularly with the binding expressions, and we'll be going through those in detail for you shortly. JavaFX properties can be readable and writable. They can be read-only properties, and of course you can also have immutable properties, which means that they don't change. Okay, so here's a code snippet. We don't need to go into the code right now. We can just show it to you up here on the slide. Here is some examples of the 4 properties that we have in our blood pressure application. What you can see is that we have 3 integer properties that are representing the systolic, diastolic, and pulse blood pressure readings. And then we have an object property that is handling the date, the local date time. And that's a generic one that you see there. And down below in the constructor from BPData, you can see how easy it is to create a JavaFX property. You just say simple integer property or new simple object property, and then we have some static strings to define those as well. But once you do that, you still have your field data, but now everything's observable, and now we can attach listeners and binders to these things. Okay. So the first thing that we'll talk about and show you is how to write a listener in JavaFX. What a listener does is it listens for changes to a property, and property changes are handled with listeners that have to be registered. You can, in a JavaFX program, add a listener on the fly dynamically and even remove it if you want to. And the idea is that a listener is a callback, so you'll get notified when the property, once again wrapping that field data that you have, when that gets updated or changes, then you can be notified. Now JavaFX gives you two types of listeners that you can implement. The first one is called an invalidation listener, okay? And an invalidation listener is notified when an observed property becomes invalid. Now that's slightly different than updating. When something becomes invalid, that means that it could have been implemented with what's called lazy evaluation, right? So that a change was made, but it wouldn't be recomputed right away. But the invalidation listener can still notify you when that happens. And so if you need that kind of implementation for both lazy evaluation and eager, an invalidation listener is probably what you want to use. The other type of listener is called a ChangeListener. And this one will be, you'll get a notification when a value updates. Well, what makes this different from the invalidation listener is that a ChangeListener gives you access to the old value and the new value, okay? And we're going to implement both an invalidation listener and a ChangeListener in the blood pressure app, and that's the first thing we're going to show you is how that works. Okay, now I think what'll be interesting for you here to see is Gail is going to go over to the application right now, and she's going to show you what we call a UI behavior, the way that the UI is interacting when a person works with it. And then after she shows you that, we're going to go back in and look at the code, and then we'll show you how we did it.
Quick question on the invalidation listener.
Yeah.
So it doesn't mean the value is invalid, it just means it needs to be recomputed?
Yes,
okay.
Yeah. That's a good question, right? It doesn't mean that it's invalid, it just means it needs to be recomputed. That's what it's for. Yeah.
Okay, so I'm going to show you just a few behaviors that we use listeners to control. So the first one is the update button. So if we select a reading and we want to change it, you'll notice the update button is not enabled. The add button is also not enabled. The delete button is. But if we make a change to one of the readings, for example, now the update button has been enabled. So we do that with an invalidation listener, and we're going to show you that in a minute. The second thing is if you change the start date, and you can do that by stepping through the data. What happens is that an invalidation listener re-invokes the filtered predicate to make sure then that the right set of data points is being displayed. And the third behavior that I want to show you is for the ChangeListener. When you select a reading, as I said before, the reading in the line chart uses a drop shadow effect just to draw to your attention which reading has been selected. And the same of when you select it in the line chart. But notice that we have to turn off the drop shadow in the previously selected item, as well as make sure the selected index in the table is set right. So to turn off the drop shadow of the previous, we need to look at the old value. So that's a situation where you want to use a ChangeListener because the old value is important. Okay, that's it. Back to you.
Okay, so let's take a look at the invalidation listener at this point. This is the code snippet from our program right here. And what you can see is that inside where we have it highlighted on the invalidation listener. And by the way, all the code that we're showing you tonight, we're going to make available on our website. So you can download it and look at it if you want to.
You wanted me to talk about this, so.
Yeah. So
Okay.
yeah, why don't you go ahead and talk about it?
We sometimes get our communication messed up. But so what you want to look in here is that we've defined a listener and we've assigned a variable name to it, and then we have attached this listener to the input controls that you saw up in the upper left-hand corner. And when any of these input controls become invalidated, then the listener gets invoked, and that listener says that if it's that if the delete button is enabled, and we're having double negatives here, that you also want to enable the update button. And sorry, but it's the disabled property, so I have to say it in those terms. It's a little bit confusing, but it is the disabled property of the button. This in reverse English, it's if the delete button is enabled, then enable the update button, and that will happen if any of the input controls detects a change or becomes invalid. Down below is the start date, which is a date control, and there's a listener attached to that. Says when it changes, then go ahead and re-invoke the predicate for the filtered list with a new range, and it detects the range then based on the value of the date property.
Yeah, and if I can just jump in for a second here, a couple things to notice here. One is when you have an invalidation listener, you can attach the same listener to more than one property, which is what we're doing here. And then the other thing to note is that when you implement an invalidation listener, you can use either an anonymous class or a lambda, and you'll see that we're using lambdas here.
Okay, and then just a little bit about the syntax. So we have a property called, for example, our spinner, and it has a value, and when you say value property within a method, that gets the JavaFX property, and that's what you can attach a listener to, or as you'll see later, use in a binding expression. So, and down below, the field, systolic field, for example, has a text property, and we invoke the JavaFX property by saying text property, and that's a naming convention. It's not a syntax of the language or anything, but it's a naming convention, and it's just like Java Beans has a naming convention. JavaFX has a naming convention. It uses the same naming conventions as Java except for the property, and this is called a property getter. Okay, so this is the ChangeListener, and recall that was the behavior where we got at the previous selected reading to turn off the drop shadow effect. And so the listener itself there's an observable, there's the old value and the new value, and so we go in here and we use that new value to find the associated data types and the node associated with them and set the effect to null, which turns off the drop shadow effect that we had put on it before.
Is the expectation this all takes place on the UI thread?
Yes.
Yes,
And I should have mentioned that. So it's like Swing. JavaFX is single-threaded, and but it does have a very, very good background task APIs. So you can do stuff in the background, and it's got really good communication. So, but yeah, you have to do everything on the JavaFX thread, and it is a different thread than Swing.
Okay, so now the cool part about JavaFX though is, yeah, you can write listeners, and you saw some sample code there, but there's actually an even more concise way to do these things, and this is with binding. And there's a bind method that you can call in JavaFX with a property, and then you can make the listeners go away, and the binding expressions will do the listeners for you behind the scenes. And this is, I think, one of the best parts of JavaFX, is if you get really good with this binding, then you won't have to write listeners as much, and also you'll be able to do this quicker, you'll be able to get it correct, and it will be easier for you to do. Okay, so tonight we're going to show you that there are 4 binding strategies in JavaFX. That would be unidirectional, bidirectional, fluent API and factory methods, and custom binding. So we're going to demonstrate 3, well, I'm going to talk about all of them, but we have 3 of these implemented in our blood pressure application, and we'll be showing you, again, UI behaviors that use these binding strategies, and then you can see how concise it is to write the code and make it all work. So let's go through a little bit about what these are initially here. Again, binding is an alternative to writing listeners, and it can be more concise and less error-prone in a lot of different cases. And binding is another great way to keep your UI controls in sync with your model data, right? Because JavaFX really encourages MVC, Model View Controller, so you separate your view from the model, and this kind of an approach with binding makes that even easier to do. All of the bindings that you see here observe their dependencies for changes and update a target property for you automatically, so you don't have to use call setters and do it all yourself. It's all done for you under the hood. So let's talk really quickly about each one of these, and then we're going to go through the examples of all 4 of them. Unidirectional binding, the one at the top here, means that you're going to update a target property when a dependent property changes. And when you do a unidirectional binding, it's actually not possible to call a setter yourself to update the property. And if you try and do that, you'll get a runtime error from JavaFX, because once you have a binding that's set up, you don't want to disturb the state of it by having a setter that be called. So if you actually tried to do that, the JavaFX runtime would give you a runtime error.
And if you need to, you can always unbind.
Which sometimes you have to do, yeah. Okay, now bidirectional binding is in both directions, okay? That means that, you're updating a target property when a dependent property changes and vice versa, okay? And in this case, because it's bidirectional, you can call a setter on the property if you have to. And JavaFX will allow you to do that, but only for a bidirectional property. Now, what they did in JavaFX that makes it very nice for a UI developer is they give you a whole bunch of libraries of predefined binding expressions. And there's actually 2 libraries available to you as a developer in JavaFX, the Fluent API and the factory methods, okay? And these are libraries of predefined binding expressions which JavaFX developers can use to implement their UIs. And we'll show you some examples of those coming up. The reason why these are convenient is they do a lot of things that UI developers have to worry about, which is conversions, calculations, conditionals, and even formatting. And a lot of these binding expressions will make it easier to do that. Now, if you have to roll your own, and a lot of times we do, right, based on things that happen out there in the real world, you can drop to custom binding. And custom binding is where you go down to a lower level and you specify the property dependencies, and you get a callback, so you override a method that you'll get a callback on. And you can do this for all kinds of things, like maybe you have to open up a file, or you have to go to an SQL database, or you have to do some calculation. This form of binding, the custom binding, is going to give you more flexibility and often will give you better performance too. Okay, so let's show you a first example with some...
I go to the...
yeah, so that's what I was going to say, is where, you go ahead and show them an example of...
Okay, so the first
So-
one we want to show you is the unidirectional bind, and I'm just going to show you the behavior, and then you're going to go and look at the code. So the behavior is, we have 4 buttons up here. This is the one that's disabled is the first button, there's a previous button, there's a next button, and a last button. And the previous button, or the next button and the last button, they're, when they're enabled and when they're not enabled, happen together. So you'll never see like the next button enabled and the last button disabled. And so because they're depend on each other, we have unidirectional bindings that say when the last button is disabled, then the next button is also disabled. It's really simple behavior. When the first button is disabled, then the previous button is disabled. So we can go back.
Okay, now if you were going to implement something like this in Swing, you would have to do a lot of this stuff yourself. You'd probably have to have a flag, enabled, disabled. You'd have to have some business logic in there to decide where you're at. Here is all you have to do in JavaFX. If you go down to the down below in the initialize method, the first two statements there it is. It's a bind, and what's going to happen here is exactly what Gail just demonstrated to you. You're binding the disabled property of the next button with the last button. So when the last button becomes disabled, the next button will be disabled. When the last button becomes enabled, the opposite, then the next button will be enabled. So under the hood, there's a listener that's being implemented by all this, but as a developer, it's one line of code to handle both of those buttons.
And the nice things about bind expressions is that they really are less error prone. If you can express the behavior of your application in a relationship like that and write it's a lot less verbose than writing a listener. You can do the same thing by writing an InvalidationListener and attach it to the last button and say, hey, when it changes, then set the next button to be the same, but it's a lot more verbose, and bind expressions are a lot better.
So the binds that you're seeing here, this is what you're going to use the most. But remember, there's 4 binding strategies, and we just talked about the first one. So now let's go and look at the second one. Now, we didn't need to do bidirectional binding in our blood pressure application, okay? But I can show you what it would look like, and I can give you an example of when you might want to use it, okay? Let's go back to the situation where you need to keep your UI control and your model data in sync with each other, okay? Because you've got the view and the UI, the view and the model separate. Okay, so let's suppose that you have a label control on your UI. So you have a text property for that, and then you have a model implementing a bean, which has a word property. Okay, so if somebody goes into the somebody changes the label, right? Then when the label changes, the bean's word property will update at the same time. And vice versa. If the business logic in your UI updates the word property of the bean, then the label will change automatically. And you can do this all in one bidirectional bind bidirectional right there to have these properties always in sync, or your, again, with this example, with your UI and your word property with one line of code. And that's pretty nice. Now, once again, we didn't have to do that in this particular blood pressure application, but this is what you would use it for if you needed to do that. Okay, let's take a look at the third binding strategy. This would be, the first part of that would be using what's called the Fluent API binding library. This is a library that comes bundled with JavaFX. It's a library of instance methods, and you chain them together with the builder pattern. You guys know what the builder pattern is, right? You know, each method returns this, so you can chain them together with dots, and it makes it very, very easy to use and also very readable as well. So the Fluent API library is divided into these categories that you see here. You can do Boolean expressions, which will apply to a Boolean property or a Boolean binding. Number expression will apply to properties and bindings for integers, longs, floats, and doubles. And most of these methods have one argument, which is an observable number value, and they're also overloaded in the library for primitive types, like ints and floats and so forth. The string expression methods, the third category, apply to string properties and string binding expressions. These guys will compare string expressions and check for nulls and things like that. And most of these methods, again, have one argument. And then the last one is a general object expression, which you can use for object properties, which are generic, and object binding, which is also generic. Okay, so Gail's going to go back into the application now, and she's going to show you another UI behavior, and then we're going to show you how we implemented that with the Fluent API binding library.
Okay, so before I talked about the delete and update button, now I'm going to talk about the add button. So it turns out the add button is only enabled when you're going to add something, and it wants to make sure that there's values in these input controls here. So if I want to add something, I'll put in some data here. And you'll notice that when I put in, when finally all three of them have data, then the add button becomes enabled. So it's, and also there's a Boolean that keeps track of the state of the application that says it's okay to add, because the other thing is that you could have, maybe you want to update, and in this case, there's data in there where you don't want the add to come on, so you have to kind of keep track of, am I updating or am I adding? So I'll show you that. Sure. Okay, so here you see the code that has the bind expression that's attached to the disable property of the add button. And again, it's disable, not enable, so you have to kind of think in the terms of negative. But this says if the systolic field is empty, or the diastolic field is empty, or the pulse field is empty, or it's not okay to add, okay to add dot not, then that is when, if any of those things are true, then the disabled property is true. And if they're all filled, all those things, then it will be true. And the enabled, oh God, the disabled property will be false.
Yeah.
And the button will be enabled. Sorry about that.
Yeah, it basically it means that all of the text property fields have to be filled in, and it has to be okay to add.
Yeah,
And
it's
then-
easier
and then the add
to
button
conceptually
comes
understand
up.
it, which is why I showed you the behavior first. It's not that hard to do, but
But as far as the
It's just
Fluent,
Boolean logic,
as far as the Fluent API is going, you can see how the builder pattern, the is empty is part of the API binding, the dot or, and there's also a dot and. So it makes it all pretty readable. It's really just one line of code, right? But it's implementing a lot of the UI business logic for you in a really succinct way. So that's another appealing part about all this, is that it just makes implementations of UI logic a lot easier to work with. Okay, now there's another part of the library called factory method binding. This is a separate library that is organized a little bit differently. It is a library of static methods that you call with the bindings class, and at least one argument to all of the methods must be observable. This has its own categories as well, so you can see they have quite a bit here. You have arithmetic bindings, numeric, relational, and logical. You can work with strings, you can do creationals, which we'll show you in a minute, and you can also work with observable lists and values. So let's show you an example of this, of what this looks like, again, with another UI scenario in our application.
okay, so I'm just going to show you two behaviors. The first one is the title for the stats chart, the bar chart down below. You see it says blood pressure stats for 15 readings, and we can step through this, and now you see it says it's for 16 readings and 14 readings, and depending on how many readings get satisfied in the predicate that we use for the filtered list, it takes the size of that and builds that title. The second example I want to show you is this, I don't know if you can see it, but up at the top it's 2 and there's a date. And as we go through and get new range of date, that date changes. And so we use a factory binding to do that. So let's go back to the code and show that to you. Okay, so the title property is the first one, and it's looking at, just takes a string, and then it's looking at the size of the systolic series. All the 3 series are the same size, so it just has to look at one. And it gets the size, converts it to a string, and concatenates it with the word readings. So it's really just a big string concatenation. And then a second one is down here, initialize start date. So we initialize the start date, and we create a label, which is a text property, and so we use a string binding. So we look at we concatenate the 2, and we get the date. We add X number of days to it, however many days we're adding at this point, and we format that, and we put it into our label text property.
Yep. Okay, so now the last one will be, remember there's 4 binding strategies, and we've gone through 3 of them at this point. This is the last one now. This is custom binding. This is where you get more control over other things, and the custom binding is a lower level technique. It uses what's called a direct extension method under the hood, and you will specify the dependencies and the compute values, and then you override a method as a callback so the system will call back to you, and then you can do things that are more complicated. Why would you use custom binding? Because the Fluent API and the bindings class doesn't have things that you need. The custom binding is much more flexible because you're at a lower level and you are controlling everything, and you can get better performance. So these are the reasons why you would do that. Okay, so our last example will be, Gail will go through and show you one more UI scenario here, and then we'll talk about how it's implemented with custom binding.
Okay, so remember when we talked about the buttons, the first button and the last button, and those were the binding dependencies, but we have to set those somehow. So we used a custom binding for the first button, and it depends on if whether or not our big list is empty, and also if the filtered list is not empty, but the first element is in range, and in range means that it's in the range of what we're showing in the filtered list in the predicate. So if the 0th element is in range, then this first button will be disabled. And well, let me show you the code. So, did you want to describe the?
Sure.
Yeah, I think you should describe.
Okay, so when you look at this, you could see that the structure of this is completely different than the other things that you saw. The bind is still there, right? So you're taking the disable property of the first button and you're binding it. But now you're using an anonymous inner class, right? So with the new that you're seeing there, okay? So what you're doing is you're creating that anonymous class, and then you make a call with super to the binder and you give it the dependencies. In other words, when the filtered list changes or the sorted backing list changes, I want a callback, and the callback is to override the compute value. So you can see that with this kind of an arrangement, it's a lower level one, and that's why it performs better. And of course, you can do anything you want inside that compute value. Now, the key thing to note here is that it's Boolean binding after the new, which means that the compute value has to return a Boolean. And I want to point out to you that when you use any of these binding expressions, whether it's custom binding or any of the other things that you did, if you don't have the types right, you get compilation errors. It's hard to make a mistake with all this. Usually when you get it all to compile and run, it's going to behave for you. You just might have to work out the logic, but there's a lot of really strong type checking to make sure that you're doing everything right here. The return statement is doing the logic there that Gail had described. If the sorted list is empty and the filtered list is not empty and it's within range, you're going to get back the Boolean value at that point, and that implements the behavior that Gail showed.
And just as an aside, there's some code that's commented out. It's kind of faded, you can't see it, but this is the same binding logic than expressed as a factory binding. So we could have used factory binding for this, but we wanted to show you what the custom binding looked like along with that.
Okay, so next slide. Okay, now we've been showing you observable properties, but there's also observable lists in JavaFX. And this is very powerful because now you can get a notification when somebody adds something to a list, removes something from a list, or you can get notified when an object inside of a list updates. And all of these things are possible through these observable types that you have. So there's an interface called observable list, which you'll see is generic. This will hold your data, and you can attach a listener to those to be notified. We are also using, as Gail said, a sorted list, which is a read-only collection, and it's wrapping an observable list and sorts the content for you with using a comparator that you specify, which is what we did in our application. And then there's also a filtered list, another read-only collection that wraps an observable list, and you use a predicate, true or false, right, to filter out what you want to go into that list. Let's take a look at what we have for observable lists in our sample application here. At the top, you'll see that the blood pressure data is the observable list for the generic there, and that's the backing list, and it's the FX collections library that you use to create these observables. In this case, an observable array list. The sorted list is in the middle, once again generic on the blood pressure data, and you can see that we're using a constructor here to create this sorted list, and then the argument in the constructor there is the comparator that the sort will use. And then finally, the filtered list down below is going to do a new to create the filtered list and use the sorting backing list behind it, and then that's the predicate. P arrow false means that it would be empty at this point. There wouldn't be anything in it. And then these are what we're actually instantiating the list.
Yeah, the very bottom of it, those are observable lists that are used by the line chart.
Okay, so our last example that we'll show you, which I think is really cool, is the ability to do JavaFX binding with streams. Okay, and you wouldn't think maybe you could do this, but you can. So we have this implemented in our program. So let's take a look at it. What you see here is that the backing list is, the setup chart bindings method is what you're looking at here. And this is called 3 times, once for each one of the line charts that you saw for the blood pressure readings. The source list is a line chart observable list, and the target list is the bar chart. So we want the bar chart to update if something happens if something changes in the line chart. And what this is doing is it's setting up the bindings so that if any of the Y values change in the line chart, then the corresponding bar chart stats will be updated. Remember, that'll be min, max, and average, right? And what we're going to do is we're going to show you how to use streams here for calculating the maximum in the bar chart, the average down below, and we didn't have room to put in the minimum, but we have that too.
It's the same as the max.
It's the same as the max, except we've got the dot min in there. Okay, so what's cool here is that this is custom binding for the max. So this should look familiar to you now because you see the override on the compute value. That's going to be the callback that comes back, right? And the source list is and the super.bind is going to be the dependency. So what all you have to do then in the compute value is take the source list and call .stream. And once you get a .stream, then you can call the map to integer method, right? Using the builder pattern here, and that will extract the Y value from the chart. And now if you want to call the maximum, just call the .max there for the stream to calculate the maximum. And then you guys know what the or else is on the bottom? You better remember? Optional, right? So what you want to do to terminate some of these streams when you're doing functional programming, things like this, is if the source list was empty, you need to supply a default value. And that's what's really nice with the or else. That just means that if the source list was empty, there wouldn't be any max, so you would make it 1 at this point. And we did the same thing down below on the or else with a 1.0 for the floating one. But by the way, just to show you, did you notice that the max is implemented with custom binding, but we're using the bindings library to implement the average. But once again, either one of these techniques can be used with a Java stream, and that's what we're showing you here, and then that's possible. You want to quickly demonstrate this? And we'll even show you how the optional or else kicks in too.
Okay, so these bindings kick in when you change the data, and you can, it's hard to see it, but the stats chart below changes as you can see the bars are slightly moving up and down as we get different data. But what I want to show you is go to the end where I know there's only 3 readings, and then go ahead and delete these 3 readings.
And that'll make the source list empty.
I don't have it deleteable. Okay, so this is the or else kicking in on each of these. They're all 1.0.
Yeah. Okay, so that finishes up part 1. Now what we're going to do after the break is we're going to take this JavaFX standalone program and we're going to put it on mobile. We're going to put it on cell phone, and we're going to talk about the issues that go along with that, and how we did it, and we're going to stay. We're going to stay in Java, and we're going to stay with JavaFX. We're going to use some frameworks that'll help us do that. So the second half of the talk, we'll take this blood pressure app and we'll put it on the phones, and we're going to actually be running it on both iOS and Android. So we'll do that right after the break. Okay? So everybody stretch your legs.